Algebra 2, Section 5.3, Translating Parabolas. A translation is just when you move something around. So all we're going to be doing is taking these parabolas and moving them around and taking a look at what happens to their equations. This is a form of a parabola, and it looks an awful lot like what we've seen before in the past, what we call the point-slope form. Notice that the only major difference here is a square on the x term. Now you can see that I've written down here where HK is the vertex. Now, there is no slope to a parabola. Remember, slopes are only for lines. A parabola has a curve, as we've seen as we've graphed them in the last few days, so there is no slope. That could be a test question or a quiz question, so make sure you know that there is no slope, constant slope I should say, for a parabola. Now if we take that equation and we solve it for k, no, it shouldn't be a k, it should be a y. Solve it for y, we get what we call vertex form, and that's the form that I showed you. It was almost the same as the form at the beginning. So this new form kind of looks an awful lot like the point-slope form, with the exception of it's being squared. Now, in example 1, we're going to ask you to graph something that's in vertex form and find its y-intercept. So remember how we would make a chart? And we would need to find the vertex. Well, it's pretty easy to tell that HK, which is the vertex here, is 2, 3. Now I know I need to go back and take a look at it again so you can see. But right here, HK is your vertex. Now, lots of students want to say, hey, that looks like negative h to me. Well, the form of the equation is x minus, just like with a line. When you used to deal with this point-slope form of the line, you plugged in a value here for the x and a value for the y, but it was always x minus and y minus. Alright? Same thing is happening here. So sometimes students like to say, well, h kind of looks backwards because it's inside with the x minus. There it is. There's h. And k is right out here. K kind of looks the same. It doesn't have any kind of weird look to it. So in my chart, 2, 3 is in the middle of my graph because that's my vertex. So we pick a couple x values above and a couple x values below and we start plugging things in. Let's say I plug in 4. Negative 1/2 times 4 minus 2 squared plus 3. And that gives me 4 minus 2 is 2. 2 squared is 4, so negative 1/2 times 4 plus 3, that would be a negative 2 plus 3, or a 1. And we know that according to our rules of symmetry, we can copy that down over here. If I plug in a 3, negative 1/2 times 3 minus 2 squared plus 3, negative 3 minus 2 is 1, 1 squared is 1, 1 times negative 1/2 plus 3, that makes 2.5. So this would be 2.5, and we can copy it down there. So when we make our graph, 1, 2, 1, 2, 3, here is that point right there. We have 3, 2.5, and also 1, 2.5. 0 we have is 1, and 4 is also 1. So there's the shape of our parabola. Now I also ask you to find the y-intercept. it shouldn't be too hard to find the y-intercept. What do you know about every y-intercept in the universe? Okay, every y-intercept in the universe has an x value of 0. This fact was really important, and you need to know that fact. So what do you get when you plug in an x value of 0? Well, we found out in our chart that we get an x value of 1. So the y-intercept is equal to 1. Now that's different from the standard form. We've talked about that also. It looks a little bit different when you're dealing with the regular standard form equation that we've been dealing with in the last few days. Okay, example 2. Write the equation of a parabola and you're given a picture. You're given a picture here. So, in this particular example, I see that the vertex is 3, 4. That's my h and k. And I've got this other coordinate, 5, negative 4. So, out of my equation that I'm supposed to write here, I already know h. I already know k. The one thing I don't know is the value of a. So I'm going to have to figure that out. I've got 3 for my h and 4 for my k. It would be really nice if I had one more point that I could plug into the equation and find it. I do. So, plug it in. Let's use this for x and y. So negative 4 equals a times 5 minus 3 squared plus 4. Now, inside here I have 5 minus 3, which is 2. 2 squared is 4. That's a times 4 plus 4 equals negative 4. Now, most kids make a huge mistake here because they think they can put those two things together. Absolutely not. You really have 4a plus 4 equals negative 4. So you will have to subtract 4 to the other side, which gives me 4a equals negative 8. And then divide by 4. And when we do that, we end up with an a value of negative 2. So now we can write our final equation of answer, which is y equals negative 2 x minus 3 quantity squared plus 4. That is our vertex form. It was easy to find h and k from the picture. We had to use the other coordinate to find the value of a. Now, write that in vertex form. And I'm going to let you do this. First, I want you to find the vertex. Then I want you to identify the value of a. And then I want you to fill in all these blanks. This one's actually pretty easy, so you should be able to do it. We already know how to find the vertex from standard form. We just need to look, pay close attention to what a is, and then write our final equation. You can practice that one. I have a practice problem here for you to try after you've done that one. So I want you to write that in vertex form, following exact same instructions I just had for example 4. And we will practice in class from some examples.